playlist, and that'll be every day. Stop there. Okay. So, how do we take these notes? Piece of paper up here. So this is your piece of paper. Like I said, an important part of notes is to be reviewable. If your notes have lots of information in them, but they're not very reviewable easily, I would really suggest that you use this method, okay? I'm going to really, in the next minute or so, try and sell you on using this method, okay? It's called the Cornell method. I'm going to change this. See it? Cornell method. You ever hear of Cornell? You ever watched The Office? You've probably heard of Cornell. Andy went to Cornell. It is a good school, despite how weird Andy is. It's an Ivy League school, and this is, I don't know, it's named after them. So it's not Joe Schmo's method, it's Cornell method. In fact, there are medical schools, and I believe some law schools, some, I mean, these are schools, what I'm indicating here. These are schools that you go to after you're done with college. You got your undergraduate degree, and now you go on to medical school where you learn to be a doctor, or law school where you learn to be a lawyer. And there are some schools that require their students to switch to this method of note-taking. We're talking high-level education here, and they are telling their students how to take notes. You would think they've finished college, they've got some method of note-taking that they can depend on, and yet they're required to do it this way. I'm not going to require you to do it this way. You're not in medical school, so if you want to take notes your whatever way, that's fine. But here we go. This is a really great way to review your notes. So, like 3 or 4 lines above the bottom, go ahead and give yourself a line across. I'll explain what it's for later. Okay. Over here, we're going to give us a vertical column to write some quick little summary notes, like an improper sentence that maybe doesn't have all of the parts of a sentence that needs to have. Like this is the length of the things we're going to write over here. Real quick questions and things like that. So however wide you want that to be, maybe a third or a quarter of the page, okay? You decide about how big you would need that to be, okay? So this big area here, regular old notes that you've always taken, you can write them pretty much however you want, okay? But let me explain how these notes are a little bit better, quite a bit better. If you're not doing something like what I'm showing you, you are just writing down these notes, and then there they sit. And then you might be able to go back to them and find a nice little highlighted section with a formula written down or something like that, okay? But what you want to do is know what at one time you didn't know. Does that make sense? Right? The problems that you have, that you feel like you knew it, but then you didn't know, like you get home and now you don't know it, because you didn't keep track of all those times that your confusions got unconfused, okay? So what you want to do is along the way, at the very least, I mean, there's lots of things you can do with this column, but here's a big thing you can do. You're going along and you have a question, you get confused about something, okay? Try and phrase that in the form of a question that you could ask, all right? So, write a question. Why did you do such and such to both sides of the equation? What does that mean? What's going on over here? You ask some kind of question, okay? Write it down. Whether you ask it out loud to me or someone else or not, write it down, okay? Because your brain is giving you this little cue that it doesn't understand something. That's a really useful piece of information since your brain is the thing that's going to be taking the test for you, right? So you want to know when your brain doesn't know something, it doesn't understand something. So you write down a question. All right? It's your brain, a little way to record things. And when you write things down, your brain is a lot less stressed. It is a lot less burdened with remembering those things. It's not good at remembering things. Okay? Just quick little things like that. So you write it down, you write the question down. Then you need to get that question answered. If it just stays a question, it's not very useful as a question. Questions are mostly useful with answers, right? So maybe you get an answer right away. That's great. Maybe you have to write a little bit more, and then it finally gets your question, or you finally figure it's time to ask it because it's not getting cleared up. Right? Whenever that answer answer comes, write down that answer, make it clear, make this question clearly answered by something in the notes. Right? And then if you want, this is a good idea, give yourself a little arrow indication, like this question is answered by this part here. And you keep going, and you get some other question comes up, and then down here you answer that question, and there's another question, and it gets answered right away, and that's great. Okay? So now what we have, once this page is done, is you can go back later on and cover this up, right? You're covering up all the stuff that you followed along fine with, and all the stuff that you were confused about, but it's all covered up, and all you have now on the side are the things that you were at one time confused about, right? And if you look at that question and your brain immediately says, I got it. I remember what the answer to that question is. I'm not confused about that anymore, and that's great. And then if you can go back again the next day, and it's like, yep, still got it. It wasn't just a short-term memory thing. I really understand that. Okay? If you come along to this and you're like, oh man, I remember asking that question, having that question, but I feel like maybe I didn't even get it answered, or and I definitely don't know the answer to it right now. Okay? Hopefully you have found the answer during class, and you can look over here, find out what is the solution to that confusion. Or if it's still a question, you still don't know it, and you don't have an answer, you need to get it answered. Right? Get that question answered. So this is about keeping track of all the times your brain tells you, I don't understand what just got said, what just got done, what you just wrote down. Okay? Keep track of those things. Your brain is going to be very helpful in telling you what you don't know. Right? Then down here, another part of this notes is just forcing your brain to think about all this information in a different way, as many different ways as you possibly can on one piece of paper. So here we're going to have a little summary. 2, 3, maybe 4 sentences on what happened on this entire page of notes. Okay? So anybody could come along to this summary, this brief summary, and know what's going on up here, and know that they would be able to find information on quadratic formula or solving one-step equations or whatever it is on this page. And don't write something lengthy here, because then you're just recreating this, and that's not really that useful. Read this over, write an actual good, clever synopsis that captures all the key points. Right? Like the guys who write Cliff's Notes, they don't just rewrite the book, they read it, they figure out all the essential elements, they summarize it, they put it down here in the Cliff's Notes, so that you can benefit from that, and you can know what all the essential parts and well, this thing meant that. This is symbolism for that thing. That's your job. You're supposed to write the Cliff's Notes for yourself down here at the bottom. Okay? Just by doing that, just by summarizing it, you're forcing your brain to go through that process of weeding out information I don't really need. I need to know the essential elements. If I do want to expand on that, it's up here. Okay? So, it's a superior way of taking notes. If you take notes similar to this, maybe just kind of make it look like this, format it this way. And the only method of notes that I've heard being required is the Cornell method of note-taking, so it might be a good idea. If you want to take notes some other way, fine, but ask yourself, are you able to go back and review your notes? Are you able to go back and pull information out of there? Do your notes help you to study? I know my notes never did. And I would go back to my notes, I just didn't. It never went back to my notes. Unless it was a very fact-based course where this happened on this date, and that's the kind of thing that was going to be asked in the test, and then my notes were useful. But in math classes, my notes were not very useful. And I didn't keep track of the things that I was confused about very well, and I wish I had known about this in school. So I'm letting you know about it. It's an excellent way of taking notes. Okay, so now we're going to move on. We're going to talk about some things. We're going to start off with fractions, okay? Because who here loves fractions and is comfortable with fractions? And these fractions are just the best. Who's confused about fractions at all? Nobody's confused about fractions? Want to raise your hand? Be honest.
Yeah.
Is there anything about fractions that confuses you?
When they're in a big long equation.
Okay. If we can understand the very basics about fractions, we can break down each problem into bite-sized pieces. If one of those pieces happens to involve fractions, then if we understand fractions, we'll be all right. So let's start with what is a fraction. Simple sample question. Okay, so let's take something like 3/5. Okay, let's just talk about fraction. I'm sure that 95% of the understanding of what 3/5 means is in all your brains, but maybe 5%, different 5% are missing. So let's just talk about it real quick. What does it mean to say the fraction 3/5? Let's talk about like this guy right here. What does it mean? Okay, that's what it's called. That's the proper name, the denominator. What is the denominator? What information does it give us about the
The
situation?
total proportion, I guess.
That the whole thing is worth, okay? The whole thing is worth 5, right? Worth 5 what?
Something.
5 something, okay. Is that 5 units, okay? So whatever the thing is, whatever we're talking about, whatever the units are, pizzas, okay, this is a very simple way to think of it. If the unit is pizzas, okay, we're talking about pizzas, then what does this tell me about pizza? It's cut into 5 pieces. Okay. So this just tell me how many pieces make the whole. Right? How many pieces in the whole? Okay, so in this case it's 5. And then this guy tells me, well, first what's it called? What's the proper name in a fraction? Not the top part, not the up there, not the, what is it called?
Numerator.
The numerator. What does it tell us?
How many pieces are 5?
How many pieces? Yeah, okay, how many of those pieces? This tells me how big the pieces are. This tells me absolutely nothing about how big the pieces are. This tells me how many of those pieces of this size I have. Or are left, or, yeah. But it's about how many we have. Okay. Size of pieces. Alright, very basic. I'm sure you feel like, yeah, I had all of that. Okay, but this is a very important thing. We're talking about we have 3 of these things. Okay? I have 3/5. Okay? And this is a thing just like any other thing is a thing, like an apple or an orange is a thing. Okay? So when we go to add 3/5 to 4/7, that's I don't like that. I'm gonna go back to let's say 2/3. Make the pieces a little bigger. I'm going to add them together. Okay. I imagine that most of us know that if you're going to add 2 fractions together, you need a what?
Common denominator.
Okay, but can you explain to somebody, a 3rd and 5th grader, why it is you need a common denominator? You can begin to explain why. In any way, on any level. Great. The size of the pieces are the same. Right now, they are not. So it wouldn't make a lot of sense to make a very common mistake, okay, that gets made. The mistake, you take a guess. What would be the most common mistake in adding these fractions together? What's that? It equals 5/8. Yes, that is the most common mistake that I would say I see as a math teacher when you're kind of at a loss. You have forgotten how to add fractions. I'm emphasizing that word forgotten because it has to do with memory. Memory is a very tricky thing. Okay? Long-term memory, very powerful. I can remember things from years and years ago, right? When I was a tiny child. But what you're trying to make work, overdrive, when you try to remember how to do something in math, or how to do something here or there. I have to check because my wife's going to have a baby soon, so I don't want to miss that. So that's why I check my phone. What was I saying? Yes, so if we're trying to remember how to do something, those are pretty pretty base level, and there's much more powerful parts of our minds that we can tap into, aside from remembering and how. Remembering is memory, how is just a process, just a procedure, is it could be completely divorced from understanding, right? I can remember a process and have no idea what's going on, okay? We want to have every idea of what's going on. That's what we're gonna work on. So if you're trying to remember how, this is a very common mistake to make. I can't remember what I'm supposed to do. I think common something, but I don't know how to do that, so I'm just gonna go for it and write this down, okay? The goal here is to at least make that mistake significantly less often. All right. So we need the denominators to be the same because we need the pieces to be the same size. And before we get into finding a common denominator, I want to look at a picture of that. And bear with me. If you already know how to find a common denominator, that's great. Then let's deepen your understanding. If you don't know how to find a common denominator, this is a fantastic place to start. Okay? It's a much better place to start than me telling you to multiply the top and the bottom by the same thing and get into this procedure. Okay? So let's get into what it looks like. Okay? So let's talk about fifths. Try and make this believable. We'll talk about thirds over here with so there we have thirds. So we've talked about how big they are. Here there are 3 of them. 1, 2, 3. Here we have 2 of those thirds. 1, 2 of those thirds. So now I'm sitting down and I have like a better drawing than this. So I'm taking a little more time to draw it out. I'm sitting down with my 5th grader that I'm tutoring, and they say, why can't this just be 5/8? You can say, well, let's look at a picture of it. Can I say I have 1, 2, 3, 4, 5 of these things? Because even when I say these, it's a pronoun that means, well, one kind of a something. This isn't one kind of something, right? Just like I can't take 3 apples and 2 oranges and say I have 5. You can say I have 5 apples or 5 oranges. And if I just say I have 5 pieces of fruit, then I've lost a lot of information. You want to retain all the information throughout this whole process. Okay? So, what is the thing? Like apples and oranges are just different pieces of fruit. What is it that's making these 2 things different? These things from these things? Their size. Let's fix the size, right? Simple thing. So fix the size. What could we do to, don't tell me I'm not finding a common denominator. What can I do to these pieces right here, and at the same time these pieces here, so that at the end I have same size pieces, and now I can cut them down smaller. Yeah. There's some number of pieces that I can cut this whole thing into and this whole thing into, then I will have the same number of pieces in both pies, both pizzas. Okay? So, how many pieces should I cut each of these into?
15.
Each of these?
3.
3. Each one of the 5 cut into 3, so it's a total of 15, right? So, let's cut this down. Let's cut this into 3 pieces, and this one, this one, this one, and that one into 3 pieces each. 5 pieces and 3 pieces each, that's 15 pieces. Okay? And we could do the very similar thing over here. Take each of these 3 pieces and cut them into 5 pieces. Okay. So I just cut the whole pizza into 15 pieces, right? So what we've just done mathematically, as we look at the 2 fractions, we have changed the denominator, right? Does that make sense? We have changed how big the pieces are. Right? This one, we had 5 groups of 3 pieces. Now we have 15. Here we have 3 groups of 5 pieces. So now we have 15. Okay? At the same time, we were cutting the whole pizza into 15 pieces. 5 pieces. There's 3 pieces each for each of the 5 pieces. Each of the 5 pieces into 3 more pieces. We took those 3 that we had, and we made more pieces. How many pieces did we make? Well, we cut every piece into 3 pieces, so we have 3 pieces, and each of those 3 pieces were cut into 3 pieces. So we have 3 times more than we had before, so we multiply this by 3. We're just counting up the pieces. Instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, I know that each of those pieces is cut into 3. I have 3 groups of 3, so I have 9 Same thing over here, I cut each piece into 5. Originally I had two of those third size pieces, but each of those 2 is now worth 5 each. 2 groups of 5, that's just multiplication. So now we have 9/15 plus 10/15, 19/15. Here's my very lowest hope, dream right now, would be that if you think that 3/5 plus 2/3 is maybe 5/8, your brain now just kind of sends off a warning and says, no, that's not right, okay? At the very least, it's not right because I know that these just aren't the same kind of thing. Just like apples and oranges aren't the same thing, fifths and thirds are not the same thing, and I cannot put them together. Even if you can't remember how to find a common denominator, just not adding them together to make 5/8 is better than adding them together to make 5/8. Okay? It's better to stop and say, that's not correct, than to just try something that's incorrect. Better to learn something right the first time, unlearn something that's incorrect, and then have to relearn it the right way anyway. Right? That's the whole idea. I will give you more credit on a test question for doing something and stopping before you make a really common mistake than I will for the person who just forged ahead and made a mistake. Okay? Because you know something's up. You know that you shouldn't go any further. You just don't know where that further is supposed to go, and you're not going to go further making mistakes. Okay? That's worth more. That shows a deeper level of understanding. All right. So at the very least, we know we should not make the mistake of adding the numerator and denominator together. Okay? The very highest hope that I can have is that you would be able to sit down with a 3rd grader or 5th grader or whoever's learning fractions these days and explain to them why you don't add them together visually, and then show them visually what it means to find a common denominator. Right? You can show them every part of finding a common denominator just with this picture. All right? The multiplying by 3 here, that's just what it takes to give both pizzas the same amount of pieces, make them the same size. This multiplying by 3, well, that just happens because I multiplied all of the pieces in the whole thing by 3. Okay. So, did you gain any new understanding that you feel is useful? Can you raise your hand if you did gain some new understanding that you feel is useful? I saw people nodding their heads. Those people should at least raise their hands. New understanding. Come on.
Can you visualize it better?
Visualize it better. Visualize. For those of you who would call yourselves visual learners, that could be a really helpful thing. We don't want fractions to be these weird things that just have rules, and then we follow all the rules. This is a terrible, terrible place to be. It's depressing and difficult and confusing. And stuff just has rules that you're supposed to follow. Okay? So, are there any questions about that?
Can you say the word for 5 here?
Say the word here.
Yeah.
Denominator.
I cannot read it.
It's I'll write it better.
Okay.
Denominator.
Okay, thank you.
If you think of a question later, let me know. Definitely ask it. We'll move on to another fractions topic. That would be when we multiply fractions. When we multiply them the way we do, why should you not cross multiply? Where does cross multiply come from? Because it didn't come from nowhere, it's in your brain from something. Okay, if you make the cross multiply mistake, let's clear it up today. Alright, so let's say we have 2/3 times 4/5. Multiply those together. So how do you remember how to multiply fractions together? How is it done? Yes?
You just take them across and then you can cancel out things if they match up.
Alright, so we multiply straight across, and if you think about it, just that you multiply straight across, if you're comfortable with that, then it would make sense that like any of the factors in any of these denominators can cancel any of the factors in the numerators as long as they have common factors, right? Okay, so you can just cross cancel the thing. We'll talk more about simplifying fractions because that's an important thing. Mistakes happen know why. But let's talk about just multiplying fractions. Why would we multiply straight across? Could you explain to someone why it is you just multiply straight across? Let me ask you this. Let's say you're in 5th grade, and I'm not saying we have any teachers like this here at this school, but say you're in 5th grade, and your 5th grade teacher teaches you that multiplying fractions, two multiplied fractions, we just multiply like this. You know, like 2 times 5 is 10, 3 times 4 is 12. And that's how you multiply fractions. And that's day one of multiplying fractions, and that's how you learned it. Do you think you would believe that 5th grade teacher?
Yeah.
Well, sure. I mean, they're your 5th grade teacher. They should be right, and they should explain things correctly. Alright. What I'm trying to make a point of here is, your 5th grade teacher didn't teach you that. But if you have made that mistake, and you don't know any different, you haven't asked the question like, why do we do this? You don't understand why we're doing it, and you will do anything your brain tells you is the right thing to do. Right? We want to get off of the emphasis of how do we do it to why do we do it. Right? It's clearly not that. It's not 12 tenths. First, I want to just quickly make a point. If I take 10 and I multiply it by a half, that means that I want to find half of 10, right? It's really 10 divided by 2, it's 5. So we get the idea that when I multiply by a fraction, it's like saying I want to find half of that thing. If I multiply 10 by 2/3, then I want to find 2/3 of 10. How big of a number is 2/3 of 10? Okay, is that making sense? So when we multiply by a fraction, what I want to establish here is we're trying to find this much of this thing. Right? How much is that? How much is 1/2 of 10? How much is 2/3 of 10? How much is 4/5 of 2/3? Okay, that's what we're trying to figure out. Then we'll see why it makes sense to multiply straight across rather than, you know, add like an x or something. All right, so let's look visually at 2/3. And for this one, it's a lot easier to look at a rectangle that's cut into pieces rather than a pie, I think. So there we have thirds. That's how big the pieces are. We have 2 of them. We have 2/3. So we start with 2/3, and we want to find how much of 2/3? We want to find 4/5. Okay. So our new number, our new fraction should reflect how many and how big these things are. Okay. So how much is 4/5? Well, the easiest thing to do if I want to find out 4/5 of something is cut it into 5 pieces and then count 4 of those things, right? So let's cut each of these into 5 pieces. Cut it into 5 pieces. There's 5 for that one. 5 for this one. And the whole thing should be cut into 5 pieces each. So in the process of just trying to find whatever 4/5 is of something, divide it into 5 groups and count 4 of those groups and see how big that is. Okay, so that first thing, in the process of multiplying fractions, what have we just done here by just cutting everything into 5 pieces? We made the pieces smaller. We made them, more abundant. They're smaller, but there's more of them, so they match up to be a whole. As far as multiplying straight across here, what have we done so far? By just cutting them each into 5 pieces. We multiply the denominators together. We have found how many pieces now make up the whole. As we're trying to find 4/5 of 2/3, we now we're working in 15ths. We've taken each of those 3 pieces and divided them into 5 pieces each. There's your denominator. There's how many pieces it takes to make the whole. Now we want to figure out what is 4/5 of the 2/3. So now we just go to each of those groups of 5 and we count up 4 of them, right? Count 4 here, 4 here. Let's see, there's just a faster way to do that. We count up 1, 2, 3, 4 of those, right? And 4 there. Until in all the pieces that we have, we count up 4 of the 5. How many do we have? We have 8. Right? We could draw a picture every time we want to do this, and divide it up and count them and all that kind of stuff. But there's definitely a faster way to count this, right? We got two groups. We had 2 to start with. We're counting 4 in each of those groups of 2, so the fastest way to count that would be addition's shortcut, multiplication. 2 groups of 4, 2 times 4, 2 times 4 is 8. So now when you multiply fractions, you see I am trying to find this much of this, 4/5 of this. Well, the new pieces are going to have to be smaller, right? To cut them into smaller pieces. So I'm going to have this many pieces make up the whole times this many pieces per each of those pieces. I have 15 altogether. And I started with 2. I want to count 4 out of the 5 of each of them on every piece. So altogether I count 8. And now when it becomes more complicated, the fractions become much, the pieces become much smaller, more abundant. It becomes easier to just do the multiplication across, multiply straight across. Now, does that make more sense than just multiply straight across? Hopefully, this helps you to understand why we would multiply straight across. Okay? So that if somebody tried to debate you and say, no, when we multiply 2/3 times 4/5, you just go like this, and like this, and there we go. It's 12/10. I mean, really, who would you be to argue that it's not that if your only argument is, no, we're supposed to multiply straight across? Who could be right there? Either one of you, because all you know is what you're supposed to do, how you're supposed to do it. You see what I'm saying? Now we want to give you ammunition in that debate to say, no, let me explain it to you. We got 2/3 to start with. We're looking for 4/5 of that 2/3. Let me show you what that would look like and what each part of this, how that relates to this picture. All right. That would be great. That's my highest dream and aspiration for you in multiplying fractions, that you could recreate something like that for somebody who's argumentative or for a 5th grader who's learning fractions. You can explain it that way. Okay, let's go. Still good, but not as much of a depth of understanding. Let's at least prove that this couldn't be right. Let's at least prove that 12/10 couldn't possibly be the product of 2/3 and 4/5. All right, so you should be able to do this too. All right, so let's follow this procedure. That's incorrect, of course. 2 times 5 is 10, and 3 times 4 is 12. I see this is a lot, and I want to help you at least get that alarm bell going off saying that can't be right. All right, so let me draw your attention to this property of multiplication. It's called the commutative property of multiplication. 2 times 3 is the same as 3 times 2. 2 times 3, 2 times 2. It's called the commutative property. They commute, they move. This one goes there, this one comes over here. And it doesn't change anything. When we multiply real numbers together, we get the same answer whether we do 2 times 3 or 3 times 2. Same with addition, not the same with subtraction and division. But addition and multiplication can switch the order. So if 2/3 times 4/5 is 12/10, I should be able to take 4/5 over here and move 2/3 over on the right side and do it that. Follow the same procedure and get the same answer. 2 times 5 is 10, so I should be able to go 4 times 3 is 12. And then 5 times 2 is 10, and now look what we have. What are these two called? Reciprocals. Now, a reciprocal is not equal to the fraction that's a reciprocal. Reciprocals are not equal to each other, right? That's not the same answer. It's not the same product. So 12/10 could not possibly be the product of 2/3 and 4/5 because we'd have to get the same thing if we switch the order of the fractions and follow the same procedure, which we don't. Okay? So things like that are a good test. Even still to this day, when I'm still wondering, is this the way it's supposed to be? And I try to explain to myself, and I at least tell myself, well, that can't be right because I should be able to manipulate the numbers, change them around in some way, and get the same answer, and I don't. So I'm doing something wrong. Something is off. You should at least be able, I hope, to have that alarm bell go off and say, that can't be right. I shouldn't cross multiply. That's not possibly the right thing. Okay? How many of you have cross multiply as like a thing in your head? It's in there, and you don't maybe quite remember what it's for? quite remember what it's for. Let's talk about what it's for.
You're looking for things.
So you're looking for what?
Yeah, when you're looking for X.
Looking for X, yes. It's when we're actually doing some algebra, right? Finding an unknown value. Okay? Let me give you a basic thing. Like I can say clean 3 cars in, let's just say 5 hours. That's probably pretty bad rate at which to clean cars, but let's just say that's what it is. So 3 cars in 5 hours. So the question, the classic proportion question, if the word proportion rings a bell, something like how many cars, right? There's the question. How many cars, and it's in the numerator, just like this is in the numerator, can you wash in 23 hours? You have 23 hours to wash cars. How many cars would you get? This is where cross multiplication is used. We cross multiply. We get 69 equals 5x. We divide by 5, and x is equal to the number of cars that I can wash in 23 hours. Classic proportions question, proportions, ratios, percents, all that kind of stuff. Remember all those? I had to use it for those guys back there, those comics. Right? The comic did not look that big on my computer screen. Right? So I had to figure out how big did it need to be. So on the computer screen, I measured it, okay? And I got this width, and this, let's call it length. We're almost done here, right? Oh well. Well, the length divided by the width of the small comic should be the same as the length divided by the width of the big comic, and so I set a proportion, knowing how big I want it to be and how big it is on the screen, and then I solve the proportion of cross multiplication. Okay? The bell has a problem. Here's what I want you to do. I'm just going to give you 2 problems for homework. Okay? Simple problems. Two what we call functions. I'm going to give you this function, okay? And a function simply is something you put something into. What do you think happens when you put something into it? It comes out. Where do we typically put things? In X. They come out at Y. I want you to put in, for both of these, 3 numbers. In some way, as blandly or as creatively as you want, keep track of this input gives me this output. Keep track of it in any way that you want. Put in this, get out this. Put in 2, get out this. Yeah? For X. Put them in for X, get them out for Y. Keep track of 3 input outputs for this and 3 input outputs for this. Thank you. Have a good day.